rock and learn!
We've heard about fractions at different times. Check out the examples in these rhymes.
I'll give you half of my candy bar.
To make the carpet fit, I need another quarter of a yard.
I need 1/3 cup of sugar to make this recipe, and 1/8 of a teaspoon of salt for you and me. Now let's learn more about the fractions we use. We'll start out easy so you won't get confused.
Hi, I'm Francis. And I know a lot about fractions. A fraction is a way of writing the part or parts of a thing or set. All fractions have a numerator and a denominator. The denominator is the number written under the bar or after the slanted line. The denominator tells you how many equal parts the thing or set is divided into. The numerator is the number written on top of the bar or before the slanted line. The numerator tells you the number of parts you are observing.
I have a silly way of remembering which is the denominator in a fraction.
Oh, hi, Dennis. How do you remember which one is the denominator?
I think of it as the downominator.
Okay, that's a good way to remember it. Now let's look at some examples of how we might use fractions. Suppose you had a package of candy bars that had 5 candy bars in it. Then the number in the set, or the denominator, would be 5. And the numerator would depend on how many of the candy bars you are talking about.
So, if my sister came and took 4 out of the package, then we could say that she took 4/5 of the candy bars.
That's right. And how much of the package do you have left?
Well, there's 1 left in here, so I have 1/5 of the candy bars left.
Hey, where did you get that whole candy bar? Can I have half?
Wait a minute, Newman. Why half? There are 3 of us now, so we should divide it into thirds.
Okay, here. You can have this little piece.
Whoa, that's not fair. I didn't get a third. All 3 parts have to be the same size for it to be divided into thirds.
Good point, Newman. Let's get a ruler and a knife. That's 2 inches for Dennis, 2 inches for Newman, and 2 inches for me.
Now I get it. You have to divide a candy bar, or anything else, into parts that are the same size and shape to use a fraction.
That's right. We call parts that are the same size and shape congruent parts. If the parts of an object are the same size and shape, they are congruent. Let's say that again in a shorter form to make it a little more fluent.
Same size and shape, congruent. Same size and shape, congruent. Same size and shape, congruent.
Cool! Now let's play a game with fractions. First, look at the object.
Count the total number of parts. That'll be the denominator.
Then count the parts that are a color other than black, white, or gray. And that'll be the numerator.
Try to say the fraction out loud before we do. Ready?
Five-sixths of the rectangle is in color.
That's right. Let's look at another one.
Four-sevenths of the rectangle is in color.
8/10 of the square is in color.
Seven-eighths of the square is in color.
One half of the arrow is in color.
Two-thirds of the semicircle is in color.
Three-fifths of the star is in color.
Six-ninths of the cupcakes are in color and even look good enough to eat.
I'd like a chocolate one. Nine-twelfths of these eggs have been colored.
We'll finish dyeing the rest of them later. But look, for now, 3/12 are not dyed.
Hey, 3/4 of these TVs have us in color.
It's been a while since I've seen a black and white TV. Now let's move on to the bonus round. These are tricky.
Hey, this hexagon isn't divided into congruent parts.
We can't fool you, Dennis.
But if we rearrange the lines like this and color in 5 like this,
then 5/6 of the hexagon is in color.
Always remember that an object has to be divided into congruent parts in order to use fractions to talk about it.
I remember congruent means the parts have to be the same size and shape. This is kind of tricky. All of these gummy bears are in color. So I'm going to say 12/12ths are in color.
Good job, Dennis. Or you can say one whole set is in color. If the numerator and the denominator are the same number, that's the same thing as describing one whole object or set. So 12/12ths equal 1.
What if we divided the gummy bears by different colors?
Do you mean divide them by red, yellow, and green?
Yes, it looks like 1/3 of them are red, 1/3 of them are yellow, and 1/3 of them are green.
Wait a minute, where did you get that they are in thirds?
Remember that a fraction is a way of writing the part or parts of a thing or set you are observing? Well, we decided to look at the different colors of the bears. Each group of the different colors are the same size, and all the bears are the same shape. So we can divide the set into 3 parts, representing the 3 colors. The fraction that describes the red gummy bears is 1/3.
But if you look at the bears separately, then the fraction is 4/12ths.
You're both right. 1/3 and 4/12ths are what we call equivalent fractions. That means we have different names for the same amount.
Is that kind of like how a person can have more than one name?
That's another way to look at it. Newman and I call you Dennis, but your sister calls you Denny.
Yeah, that's my nickname.
Equivalent fractions are like a nickname. Whenever you see them, you know they're the same. They're the same amount if you have an
Let's look at some more equivalent fractions. If we have a piece of paper, fold it in half, and open it up, how many parts do you see?
I see 2 congruent parts.
So, if I color in one of the parts red,
Then 1/2 of the paper is red.
now watch this.
Oh, I see. Now it shows that 2/4 of the paper is colored in red.
So 1/2 and 2/4 are equivalent fractions too.
Now you've got the idea.
Here, let me try.
1/2, 2/4, and 4/8 are all equivalent.
Super! Let's practice identifying equivalent fractions. We'll sing while we look at the pictures and then decide if they are equivalent or non-equivalent. Try to say equivalent or non-equivalent before we do.
Equivalent fractions are like a nickname. Whenever you see them, you know they're the same. They're the same amount. If you have any doubt, just take a look at them. Check it out.
Let's see. We have 4/6 of this cake left.
And there's 8/12 of this cake left.
So are they equivalent?
Yes.
Equivalent fractions are like a nickname. Whenever you see them, you know they're the same.
I see 2 halves in this sandwich, or should I say, a whole sandwich.
There's a hole in your sandwich?
Not yet. I'm waiting for you to check yours before I eat any.
Well, I just ate 1/4, so there's only 3/4 of the sandwich left.
So are they equivalent?
No, they are non-equivalent at this point.
Equivalent fractions are like a nickname. Whenever you see them, you know they're the same.
5/8 and 8/16. Non-equivalent.
If I ate one more piece from the one with 5/8, then it would be 4/8. And 4/8 and 8/16 are equivalent.
Great! I think we have the idea. Let's move on to the bonus question.
If 10 kids were together in a group, 5 of them boys and 5 of them girls, what 2 equivalent fractions could we use to describe the number of girls?
Well, the easiest fraction would be 5/10. 5/10 of the kids are girls.
And the other fraction would be 1/2. Half of the kids are girls.
Yes, but explain how you got that answer.
Well, I saw that I could divide the one large group of kids into 2 groups, the boys and the girls. And since there were an equal number in each group, then I figured that I could use 1/2 to describe the girls.
Impressive. But if there had been 6 girls and 4 boys, we couldn't have done that, right?
That's right. The smaller groups have to have the same number in each group.
Hey, look! 2 pies divided into 4 pieces each.
Now that's what I call pie in the sky. Oh, great. Now we only have 5 pieces. Wait a minute. That's 5/4. How can this be?
It's okay. We can have more than 4/4 because we started with 2 whole pies. 5/4 is what we call an improper fraction.
So, all of the other fractions were proper fractions?
That's right, Newman.
If the smaller number is up on top, that's a proper fraction. The numerator is smaller than the denominator. But if the bigger number is up on top, that's an improper fraction. The numerator is bigger than the denominator.
at some more examples to make sure I've got this straight.
Sure thing. See how fast you can say the fraction of the pieces in orange. Then say whether the fraction is proper or improper. Three halves. Improper. Seven eighths. Proper. Two fifths. Proper.
Wow, you almost fooled me with that one.
Well then, take a look at these. 11 fifths. Improper. Three fourths. Proper. Four thirds. Improper.
I just noticed something. 3/3 of a circle is the same as one whole circle. And we have 1/3 of another circle.
Boy, you catch on fast, Newman. Another way to write 4/3 is 1 and 1/3. This is called a mixed numeral because we have a whole number and a fraction mixed together.
Mixed numerals, huh? Maybe you should show us some more of these mixed numerals so I don't get mixed up.
Okay, let's look at the improper fractions from the last examples and turn them into mixed numerals.
With these two triangles, one is colored in orange and 1/2 of another one is colored in orange.
So 3/2 is the same as 1 and 1/2.
Fantastic!
Let me do this one. 2 whole rectangles and 1/5 of another. So 2 and 1/5 are orange, right?
Way to go! All this talk of orange reminds me. My dad bought some boxes of oranges that he wants to divide equally between the people in our families.
Including me, we have 4 people in my family.
5 people are in my family.
Okay, if we add the 9 from your families to the 6 from my family, we have a total of 15 people to divide the 33 oranges by.
Here, let me do that on my calculator. We each get 22.
That can't be right. Here, let me see that. That says 2.2.
2.2, huh? That's a special kind of fraction called a decimal. 2.2 is more than 2, but less than 3. It can also be read as 2 and 2/10.
A decimal is a fraction. And to find out what you've got, count the number of places to the right of the little dot.
1/10, 2 hundredths, 3 thousandths. 1/10, 2 hundredths, 3 thousandths.
You can keep on going as long as you need. Just keep adding zeros out to infinity.
Ooh, that's a lot of zeros.
Don't worry, Dennis. We'll start off with just one number to the right of the decimal. That's called the 10ths place.
Hey, I think I know why. It's the 10ths place because you can show the same number in a fraction with 10 as the denominator.
You sure can. Let's say we have a square cut into 10 equal parts. If 3 of the lines are colored red, we know we can show that fraction of the square as 3/10. We can also write this fraction as the decimal 0.3.
That makes sense.
Let's do some more.
Okay, look at the picture of the square and take turns saying the fraction and the decimal. Newman, you go first.
1/10 or 0.1.
7/10 or 0.7.
2/10 or 0.2.
5/10 or 0.5. Okay, I get that. But what if we have two numbers past the decimal?
Remember our song?
A decimal is a fraction, and to find out what you've got, count the number of places to the right of the little dot.
1/10, 2 hundredths, 3 thousandths.
1/10, 2 hundredths, 3 thousandths.
So, two numbers would mean we have hundredths.
We're going to need a lot more pieces.
Let's just divide each of the rectangles into 10 equal pieces. Now our square is divided into 100 smaller squares. If 3 full columns and 5 squares of another column are colored red, that's 35 out of 100 squares that are red. We can write that as 35 100ths, or 0.35.
Let me try one. Let's see. One full column makes 10 squares, and 3 more makes 13. That's 13 100ths, or 0.13.
I'll do this one. There are 7 full columns and 1 more square colored red. So the fraction is 71 100ths, or 0.71.
My turn! This fraction is 20 100ths. So in decimal form, it's 0.20.
Very good! Now look at this one.
Only 2 squares are colored in, so that would be 2 100ths.
Correct! And to write the decimal, you have to be sure to put the 2 in the right place. So this one would be
0.02.
outstanding! I believe you have it down.
What if I have a fraction like 2/5 and I want to write it down as a decimal? How would I do that?
You can't do that. The denominator isn't 10, or 100, or 1,000, or...
Hold on. It's time I let you guys in on a little secret.
I knew it! You've been hiding something from us.
Oh, man!
Calm down, guys. This is really simple. A fraction with a numerator and a denominator is just like a division problem.
Divide the numerator by the denominator.
That's the way to get the decimal number.
Divide the numerator by the denominator.
Oh, come on now, I told you how.
Divide the numerator by the denominator.
That's the way to get the decimal number.
Divide the numerator by the denominator.
Come on now, I told you how.
Can I use my calculator?
Sure, Dennis. 2/5 is the same as saying 2 divided by 5. What did you get?
Hold on. 0.4.
That's 4/10. So does that mean that 2/5 and 4/10 are equivalent fractions?
Newman, my man, you catch on fast.
Cool! Try 1/4. That's one of my favorites.
0.25. That means that 25 hundredths and 1/4 are equivalent fractions too, right?
Yep. Hey, this is pretty neat. Let me try one. Let's see. 1/8 would be 1 divided by 8, which comes out to 0.125. So 125 1,000ths is equivalent to 1/8.
So, will this work with any fraction that has a numerator and a denominator?
Yes, it will. You may get a very long answer, though. It may even be too long for a calculator to show you all of the decimal places. Sometimes the decimal even goes on forever.
What are you talking about, Francis?
Yeah, how's that possible?
Let's try 1/3. That's simple enough, right?
Right. I'll just punch it in and... Whoa!
Wow, the 3's fill up the whole display.
And if you do this by hand with long division, you'll see that they keep going forever.
What should we do then?
Don't worry about it too much. The further to the right of the decimal point you are, the smaller the number is. We can pick a spot to stop and look 1 decimal place to the right. If that next number is 5 or larger, we'll round up to get an approximate answer.
And if the next number is 4 or less, then we just chop off the extra digits. That's a good way to get close to the number. I'll just be sure I go out enough decimal places to get the precision I want.
Good plan, Newman. Sometimes that's what you have to do. And sometimes it's best to leave the fraction written with a numerator and a denominator. We're almost finished, but you will learn many more things about fractions and decimals later. For example, you will learn to add, subtract, multiply, and divide fractions.
Hey, I heard that it's easy to add and subtract fractions if they have the same denominator.
You heard right, Newman. Let me show you why. Look at this sandwich divided into fourths. How many fourths are here?
It's all there. There are 4 fourths.
Now, if we take away 1/4 and give it to Dennis, how many fourths are left?
3 fourths are left.
So, if we write it out, we have 4 fourths minus 1/4 equals 3 fourths.
I've got it now. If you want to subtract 2 fractions, things can get rough. But we learned something easy just now that makes it not so tough. Look at the denominators. Make sure they are the same. Then subtract the numerators. That's how we play this game. Put the difference of the numerators above the denominator. Put the difference of the numerators above the denominator. Let's do it!
If we start with 4/5 of this star
and take 1/5 of the star away,
we get 3/5. 4/5 minus 1/5 equals 3/5.
We have 8/9 of this rectangle
minus 4/9 of the rectangle
means that we have 4/9 of the rectangle left. 8/9 minus 4/9 equals 4/9.
There's 5/7 of this circle.
Take away 2/7 of the circle,
and we have 3/7 of the circle left. 5/7 minus 2/7 equals 3/7.
Whoa!
Hey, wait a minute. Where's Dennis?
Looks like he got taken away.
Say, that means that 1/3 of us got taken away.
And there's 2/3 of us left. 3/3 minus 1/3 equals 2/3.
Wow, subtracting fractions seems easy if the denominators are the same. How about adding fractions?
That's just as simple.
So, if you want to add 2 fractions, it can be fun for you. Make sure the denominators are the same, then here is what you do. Put the sum of the numerators above the denominator. Put the sum of the numerators above the denominator. Let's do it!
If we start with 3/8 of this square
And add 2/8,
we get 5/8. 3/8 plus 2/8 equals 5/8.
we have 1/6 of this triangle,
Plus 4/6 of the triangle
means that we have 5/6 of the triangle. 1/6 plus 4/6 equals 5/6.
There's 2/5 of this semicircle.
If we add 1/5 of a semicircle,
We have 3/5 of a semicircle in all. 2/5 plus 1/5 equals 3/5.
we have 3/12 of this rectangle,
Plus 4/12 of the rectangle
means that we have 7/12 of the rectangle. 3/12 plus 4/12 equals 7/12. Cool, Francis. Adding and subtracting fractions that have the same denominator turned out to be pretty easy.
That's right, Newman. But that's just the beginning. Now everyone can practice using fractions and decimals in the world around them. And someday we will learn how to add and subtract fractions with different denominators and do many other cool things using fractions and decimals.
We've learned about fractions of